This video is going to talk about accuracy and precision. This is for chapter 2. So, when we're in science class, the numbers we use are not just numbers like they are in math class. They're always a measurement. A measurement is going to give us something slightly different than a number. A measurement always has some kind of uncertainty in it. Let me give you an example. It might be helpful for you to draw on your packet what I'm about to draw. This would be an example of a graduated cylinder, let's say. And in this graduated cylinder, let's say these are my markings for the line between, there's a 10 milliliter and here's an 11 milliliter. Now when we pour in, say, some liquid, like let's say water, when we pour that in, it does not pour in with a flat line, it pours in with a curve. Some of you might remember in 9th grade science, we called that curve the meniscus, okay? So let's say it's filled all the way up to the almost to the 11 milliliter mark. Now, it's your job as a scientist and a chemistry student now to record that measurement. Now, if you look, you know that this is definitely, at eye level, we always want to read the bottom of the meniscus. You know that it's definitely between 10 and 11. It's not 11 yet. And we would have to estimate that last digit. We're not sure what that is. I would say that it's definitely more than half way through, but we don't know what point it is. So we might say 10.8. That might be our best guess, but I'm estimating that 0.8. It could be that it's actually 10.9, or it could be that it's actually 10.7. But my estimated digit is my uncertain digit. And so because we have uncertainty in measurements, we have to be as accurate and precise as we possibly can be. Now, accurate means we're going to try to get a measurement that is as close to the real or accepted value as possible. That's what accuracy means. Think of it like throwing darts at a bullseye, at a dartboard. You want to hit the bullseye. That would be accurate. Now, to be precise, it means that we're very good at repeating our measurements. So if we're going to throw several darts, we'd want to be precise by hitting them roughly in the same place. Here's a diagram to show you what I'm talking about. If we look at these first two, in this box number 1, let's call this, we're both accurate and precise. The reason it's accurate is because all of the shots are in the bullseye, and the reason it's precise is because I did that more than one time. Accurate because I'm hitting the bullseye, precise because all of my shots are there. Now in box number 2, if you notice, all the shots are right here, okay? It's not accurate because I'd like them to be here in the bullseye. That's where I would have wanted them to go. But because they're all close together, it's precise. So precision has to do with repeatability. If we move down to the next set, in box 3, if you'll notice, I'm getting closer. If you look where all these shots are right here, they're close to the bullseye, so we could say that our accuracy isn't bad, but they're all over the place. I have shots kind of everywhere, and so because they're everywhere, it's not precise. And in box number 4, I'm neither accurate nor precise. If you look, my shots are everywhere. They're not really close to the bullseye, and they're kind of all over the paper, so therefore, I'm neither accurate nor precise. In science, you want to be both. You want to be both accurate and precise if possible. You want your answers to be as close to the right value as they can be, and you want to do it the right way every time you do it. So now you have the difference between accuracy and precision.